to next week. It's going to be 2.5 hours, 14 hours to 16:30. I think so. And so it's 2.5 hours. You can prepare 3 pages of cheating sheet. So half of the quiz will be related to the residue and residue integration, and the other half is partial differential equations, including whatever we are covering today. So actually, after quiz, we have one more week to cover the last topic. Actually, almost done with what I planned for this semester. So I think maybe postponing one more week for quiz will be better for you to prepare for your final. So the topics that we are covering these days is a new subject that I haven't used it for the previous classes. So I may have need some sheets that I prepared. So about 2 weeks ago, we first to the partial differential equation. Can be found from the 2 solutions of ordinary differential equations. And from this, we have 2 independent solutions. U, x, y, z is some constant. Phi, x, y, z is constant. Then general solution is either some function u phi is 0 or phi is some function of u. Those are the general solutions. And why this is true that I proved I wrote down the statement of a theorem and then also proved it, right? So I'm not going to repeat it, just give some examples. So, as an example, for example, P is y plus z. Actually, I covered it last 2 weeks ago, but I'm going to repeat it again to refresh your memory for how to solve these problems. And so many of you have complained that my handwriting is fast, so I tried to speak slowly and write slowly as much as possible. And those of you who might have some questions, actually one student asked me to have a office hour this Friday. So this Friday, time is Friday is 22nd, right? Let me check. Yeah, I will have an office hour from 2 to 4. 14 to 16 hours at room 226, this building. So if you have any questions, you can stop by in my office and knock the door. Or maybe if you want to make an appointment for time, you can send me an email. So that's a notice of office hour. I was hoping that my YouTube class give you enough chance to review the material, but still, some student might want to ask a question. So it's open for 2 hours this Friday, and the second floor upstairs. So let's say, you can apply this formula. So this is y plus z dx, x plus z dy, x plus y dz, right? So from this, what happens if you add them all together? If you add them together, right? Then we have a twice over x, twice over y, twice over z, right? So we have twice of x plus y plus z, dx plus dy plus dz. This can be written as this way: 2x plus y plus z, dx plus y plus z, right? Or if you subtract this, what happens? Dx minus dy, and there are z here, so it will be cancelled. So minus x minus y, or dy minus dz minus y minus z. Or I think it's better, it's maybe convenient to have dx minus dz minus x minus c, right? So we can compare, or maybe summarizing next page. I guess I'm going slow enough, right? Still too fast? So we have, oops, what's the, no, that's the paper. Something is very strange. Where is the moving button? Something is changed. But they didn't ask me this comment before. I hope not. So we have dx plus y plus z twice of x plus y plus z equals minus dx minus y, x minus y, dx minus z, x minus z, right? So we can solve these two equations first. What happens? You can integrate. Then 1/2 ln x plus y plus z equal minus ln x minus y is constant, or ln x plus y plus z plus twice of ln x minus y is constant, or ln x plus y plus z x minus y squared is constant. So one solution is something like that. U is x plus y plus z, x minus y squared is something like a is constant. It's a solution, right? From these two, we can have ln x minus y minus x minus z is constant. So ln x minus z, x minus y is constant, or we can set v as x minus c, x minus y. So general solution is something like this: phi x plus y plus z, x minus y squared, x minus z, x minus y is 0 is all. The general solution. And of course phi is arbitrary function. We do not know the function because we don't have enough conditions to determine it. And we are going to see the further conditions that can be used to determine the functional form of phi. Another possibility is we can use either another form of solution is either u is psi v, or v is something like psi v u. So for example, x minus y over x plus z, x minus z is some function psi x plus y plus z square x minus y square. No, is also solution. So we do not know the functional form yet. So, okay. Another example. X t partial x partial z, y partial x partial. Sorry, let me just. X partial z, y partial z is z. And solution represent a surface parameterized by x equal t, y equal 2t squared plus t, z equal 1 plus t to the cube. So this is a condition. For determining the arbitrary function. So if this condition is given, so x equal t, y equal 2t squared plus t, z equal 1 plus t for all t. Then P is X, right? Q is Y, R is Z. So the X over dx, Y over dy, Z over dz. So maybe we can start with this 2. This is arbitrary. Then dx over x is z over dz. ln x minus ln z is some constant, right? So ln z over x is constant. So we can set u is z over x is some a. Likewise, we can choose x over dx equal y over dy or ln y minus ln x is constant. Then ln y over x is constant, or v y over x is constant. So we have two general solutions. One this part and another this part, right? So we're going to use the u is z over x v y over x is a general solution for it. Then we are going to find out u is some arbitrary function of v, or z over x is arbitrary function of y over x, or z is x times phi y over x. So condition z is 1 plus t cubed, x is t, y is 2t squared plus t, right? So v is y over x is 2t plus 1. So let's set this is as a w. Then t can be changed into w minus 1 over 2, right? So 1 plus 1 over 8 w minus 1 to the cube is t was 2 1 over 2 omega minus 1 phi omega. So actually we can determine omega, right? So phi omega is, you can divide by this, so 1 over 4 omega minus 1 square plus omega minus 1 over 2. And omega is nothing but y over x, right? So see from this x times phi over y over x, and we know the form x times 1 over 4 y over x minus 1 square 2 over y minus x minus 1. So in this case, we can actually determine the functional form. So this is our solution. So arbitrary function can be determined, right? If you properly given the condition for the solution, like a surface. The solution, actually, we require the solution from certain kind of surface. Then we can specify the form of a particular solution. So any questions? So last week we found that partial differential equations are useful not only for engineering problems, but some financial engineering problems too, right? So I hope that motivates you well, that if you know partial differential equations well, then you never know. You may be able to make some big money. Or maybe one day some of you will find a new equation, new formula for some securities like a stock or options, and then maybe get the Nobel Prize, right? So the Black-Scholes equation is a very simple form. I mean, I wouldn't say simple, but it's a well-known equation called heat equation that has been known for almost 200 years. And Black and Scholes just have found out that, I mean, you can transform some given partial differential equations for options, then by some very wise choice of variables, change of variables, then it can be transformed into heat equations, and solutions are already known. So you can transform those equations back to the original Black-Scholes equation, then you can find the formula for the optimum price for how to buy the options or sell the options. So partial differential equations has so very many useful applications. And so I was hoping that this is the reason one of the reasons I have chosen this as my last topic for this semester. And I was hoping that mathematics, or advanced mathematics such as partial differential equations, may be very useful. So you give some motivation to look for some more mathematics in your career. Okay, where is another example? Let's try to do the simple example again. X x partial z minus y partial z is z, such that p partial x partial z 3 times partial y partial z is 3q when x equal to 2. So this is another condition. In case of a Black-Scholes equation, the condition was the final condition, right? So at certain time of maturity, that condition for the option is stock minus C over 0. So likewise, so you can set many different kind of conditions for the partial differential equation. So we have x dx minus y over dy, c over dz. So we can start with this. As before, ln z minus ln x is constant, or z minus x u is constant. Another condition comes from here. dx over x equal minus y over dy, or ln x plus ln y is constant, right? Or v is xy is constant. So let's set the general solution is given by u is some function of v, or z equal x times phi over xy. So this is v, right? So p is c to the x, right? Partial x partial z is, we first differentiate by x, then we have phi. And we have x phi u, partial x partial v is y. So phi v plus xy phi prime v, right? Let's use this space q zy partial y partial z is nothing but x times phi v partial y partial v is x square phi v, or x square phi dash v. So here so p zx partial z is phi xy plus xy phi dash v. Q is cy partial y partial z is x square phi dash v. So at x equal to 2, what happens? Phi 2y plus 2y phi dash equal 4 times phi dash. This is 3. Times 3, right? Because condition gives us 3 times. P is 3Q. So it's 12 phi dash 3. So 2y is actually 3, right? 3 was xy. That's 2y, right? X equal 2. So this is 3. So 5v plus v minus 12 dv d phi is equal to 0. Or v minus 12 dv d phi is minus 5v. Phi over d phi is minus v minus 12 over dv, right? So that means ln phi plus ln v minus 12 is constant. Or phi v minus 12 is some constant c. Or phi is v minus 12 or c. This is constant. So the solution is following. C is x5v, right? From the previous note. So we have x times xy minus 12 over c. So solution is not complete yet because we still need some constant to determine. But at least we are getting close to, we actually determine the form of a function. So getting close. But from the engineering point of view, most important partial differential equation would be second order. So can I move on? PDE. So we summarize the notation first. So zx partial x partial z, zy partial y partial z, cxx. So I'm going to use subscript to denote the derivative to save the notation. Partial x partial y partial square z partial y square. So those are called subscript. So just if we make a detour, something superscript. This is a TOEIC word. So it came from Greek, script is word or letter. Super is up, sub down. So what do you call the way under the ground? Subway, right? So they are from Greek. And what's Holy Script? Holy is venerable, 성스러운 or venerable. So Holy Script means Bible. So it can be the prejudice of a Western civilization. So there can be different Holy Script like Buddha, 불경, or Quran or whatever. But well, that's what they decided to describe the word for Holy Script as a Bible. So anyway, the subscript will be used to denote or specify the derivative. So denote is, do you know note? This is my note, right? In Latin, you can make a noun into verb by putting something. So denote is write a note. It's a verb of a noun note. You can put D or EN. You can put D or so. It's a trick. Anyway. So I forgot the name of the author, but if you know the origin of the English word, Greek and Latin, then you can enlarge your vocabulary very efficiently, I think. The author is, let me check, Google. Okay, word power made easy by Norman Lewis. This is not a it's not very difficult book about this size, and it explains the origin of English in terms of Latin and Greek origin. From Latin and Greek. So I think I took a detour. So I think it would help you to enlarge your vocabularies. For example, there are many ortho is a Greek word for straight. PD is a bone for Greek. So you can put these two words like orthopedic, pediatrician, 정형외과 의사, orthodontist, 치열교정 의사, pediatrician, 소아과 의사. Because when in the ancient times, the young people were very easy to break their bones, right? So in Greek time, the pediatrician is usually the doctor specified correcting the broken bones of kids. So pediatrician is a 소아과 의사, something like that, etc., etc. So you can enlarge your vocabularies by learning the origin of, because English words, I think about half of English words came from Latin and Greek, and about 30% from French. Okay, so why I'm doing this? Okay, so I was explaining that I'm going to use subscript to denote, saying the denote is define the derivative, and I was talking about the origin of subscript from the Greek word and etc. etc. So I think if you're still sophomores, you have plenty of time. So if you can find this book, then I think that'll be very helpful to memorize the word. I mean, if you understand the origin, then much easier to grab the meaning of a word and easy to memorize. For example, Korean, I think about 60% of Korean words came from Chinese, right? So if you know the Chinese letters and the meaning of those Chinese words, then you can enlarge the vocabularies of Korean very efficiently. And so at least you can increase the vocabularies, English vocabularies, by maybe twice, learning the origin. So before I proceed, maybe you can take a break for a few minutes. What do you think? So we are going to study the second order differential equations, partial differential equations, given by the following form. Or so A, B, x, y, z, c, x, y, z is a continuous function. X, y, z. Continuous function is called 연속함수. So, I mean, fx is called continuous if for small epsilon delta continuous at x0 x minus fx0 for x minus x0 is delta. So when x is changing very small, then f is changing very small, then we are calling the function is continuous. So continuous function is a prerequisite for defining the partial differential equations. And we classify the partial differential equation of second order as follows. Hyperbolic b squared minus 4ac is larger than 0. Elliptic b squared minus 4ac is equal to 0. Parabolic sorry, this is parabolic. Elliptic b squared minus 4ac is less than 0. Have you learned about the Laplace's equation in electromagnetic theory? 전자기학, 라플라스 방정식? Raise your hand. You have learned it. For example, Laplace equation. Zxx plus Cyy is equal to 0. There's a Laplace equation, potential equation. So A is equal to 1, B is equal to 0, C is equal to 1, right? So B squared minus 4AC is minus 4 is less than 0, right? So Laplace equation is a typical example of an elliptic equation. But it's more convenient to make a transformation. So a bit complex to find the solution. By the following transformation. By introducing new functions u free x, y, z, and we write down z x, y as z u x, y then Zx can be written as partial u, partial z, partial x, partial u, right? Plus partial v, partial z, partial x, partial v. So you can put down zu, ux, c v, vx. Likewise, zy. Those are the chain rules. Right? You learned when you were in freshman. So we can do the same thing. Partial u, partial z, partial y, partial u plus partial v, partial z, partial y, partial v. So z, v, zu. It'll be easy to confuse. So I'll write zu, uy, z, v, y. How about zxx? This is actually zu, ux plus c3, 3x, x, right? So it can be written as cu, x, ux, right? Plus cu, ux twice, c3, x, 3x twice. So, you just need the mental calculation for subscribed as a derivative. So, this is a z, u, ux, right? And z, u, 3, 3x, ux, right? Something, I think I missed something. Plus c3, 3xx, right? Plus cu, uxx. Likewise, c3, ux, c3, 3x plus c3, 3xx. So if we arrange the terms carefully, then we have, so this can be written as cuu, right? So we have cuu, ux squared plus cu3, ux 3x plus cu, uxx plus z 3u, ux 3x plus c3v, 3x squared plus c3, 3xx. Don't worry about that. I'm going to rearrange in the next page. So I'll let you copy, if you need time. Okay. So zxx is CUU UX square twice of ZUV UX 3x CVV 3x square ZU UXX C3 3XX and likewise 같은 방법으로 ZYY can be we can obtain the same thing, right? So I'll just follow the result ZUU UY square plus twice of ZU3 UY3Y C33 3Y square CU UYY C3 3YY. So actually this can be homework. You can check it as a homework at home. And ZXY, this can be Y, right? Or ZUUX plus C3 3x to the Y. So U Y 3 3Y UX plus CU UXY and likewise C3 U UY C3 3 3Y 3x plus C3 3xy. So what happens? Likewise CUU UXUY CU3 no CU3 UX3Y CU UXY plus C3U UY3X plus C33 3X3Y plus C33XY. Oh, so Z UU UXUY CU3 UX3Y plus UY3X plus CU UXY C3 3XY plus C33 3X3Y. So we substitute this into just keep notation. Just you need to be patient. If you think I'm going too fast, I'll slow down. But you need to copy. By the way, any announcement for the engineering math competition? 공학 경시대회, 공학수학 경시대회? No announcement? I think usually they announce around this time. 공학 수학 경시대회 usually first week of December. You might want to check at 시립대 홈페이지 or whatever. So you just let's substitute the original equation. So A CXX B CXY C ZYY. You just need to write down once again. And so A CUU UX square 2ZUV UX is VX C VX square CU UXX CV VXX plus P CUU UX UY CUV UX VY UY VX CVV VX VY plus CU UXY CV VXY plus C, same, CUU UY square 2ZUV UY VY CVV VY square, VY square ZU UYY CV VYY. Just be patient. So let's check for this ZUU. What happens? A UX square B UXUY CUY square ZUU, right? And for UV, this. So we have twice over A UX VX plus B UX VY plus UY VX 2C UY VY Z UV plus A now VX this A 3x square B where is B? B U 3x 3y C 3y square C U V plus how about CU? Single U has A UXX B UXY CUYY ZU plus A VXX P VXY C VYY Z V is some function, new function form U V Z CU CV. So we are going to call this as alpha. This beta, this is gamma, this is delta, this is epsilon. Then everything becomes alpha beta ZUV gamma ZVV plus delta ZU epsilon ZV is F UVZ. So you may ask a question, why do we this very complicated things? I mean, it doesn't change that much. So, I mean, we made the coordinate transformation, and all we did is finding a new form of differential equations, right? So, even more complicated. So why are we doing that? So that can, I hope this is obvious in the following example. That is alpha, right? That is alpha. Alpha is AUX squared plus BUXUI plus CUI squared. So, see? So, it's twice, right? So original equation is A ZXX plus B ZXY plus CZYY is some function XYZ ZXCY, and we transformed into alpha ZUU beta ZUV gamma ZVV plus beta Z, not beta, delta U epsilon V is some new function U V Z ZU ZV. So it should be same as F, but if you represent F in terms of this new form, this is OF. So you can see the following is obvious. So let's consider the hyperbolic case. Hyperbolic case is b squared minus 4ac is greater than 0, right? So consider the second order equation. AR square BR plus C equals 0. For some variable R. Then because of how many real roots you can have? 2, right? So R has 2 real roots, right? Okay, let's say called mu and lambda. So we can find mu and lambda, and then we set ux over uy as lambda and vx over vy as mu. Then what happens? That means ux over uy is a solution and vx over vy is a solution, right? Of AR square plus BR plus C equals to 0. Then very interesting case. So ux over uy is a solution, right? So we have the following. Where is A ux over uy square plus B ux over uy plus C is equal to 0, right? And because we assume that this ux over uy is a lambda solution, right? Or A ux square plus B ux uy plus C uy square is 0. Something familiar? What is that? That means alpha is 0, right? Likewise, if you assume A over Vx over Vy square plus B Vx over Vy plus C is equal to 0, or A Vx square plus B Vx Vy C Vy square is equal to 0, this means that gamma is 0, right? So then PDE becomes just beta ZUV is F minus delta ZU minus epsilon ZV. The original hyperbolic second order equation has both the original hyperbolic equation PDE AZXX PZXY CZYY is F, right? But so we have to find out the second order derivative of Z, Y, and also XY. Three second order derivative, but we have only one, right? So if you make a transformation of UV, then we can solve only one second order equation for UV. So this is actually simplified. And the solution UX over UY is lambda, and Vx over Vy equal mu is called characteristics. So it's a notation, name of a solution function. So we can simplify the partial differential equation, second order partial differential equation, considerably by reducing the second order derivative with just 1 from 3. So we reduce the complexity of our partial differential equation by 1/3 by introducing the characteristics. Of course, we need to see some example. So characteristics can be found the following way. And characteristics from the following equation: dx dy is minus uy ux. Or dx dy plus lambda equal to 0. dx dy is minus vy vx. dx dy plus mu is equal to 0. So consider the following example. Zx plus 2zxy minus 6x squared. Zyy is equal to x minus 1 cx. So a equal to 1, b equal to x, c equal to minus 6x squared. So find the characteristics. Step 1. So r squared plus xr minus 6 x squared equal to 0. So we can factorize r plus 3x r minus 2x equal to 0, right? This is a middle school problem. 1, 1, 3x, 2x. So you can factorize. So r 2x, r2 is minus 3x. So let's say lambda, this is mu. So characteristics can be found the following way. So dx dy plus 2x equal to 0, or dx dy minus 3x equal to 0. So general solution of this is what? Y plus x squared, right? Is some constant. This is y minus 3 over 2x squared is C2. So we can actually set number 2. So U as a set as a y plus x squared, V as a y minus 3 over 2x squared. So I don't have enough space, so let's move to the next page. But before I do that, I'd like to let you finish your copying the equations. And maybe it may be better for you that today I'll just cover briefly the hyperbolic case and stop and leave the parabolic and elliptic for after quiz. So it may be better for you, right? Because it will reduce the amount of material that you need to study. So just be patient, maybe for another 20 or 20 minutes. And then so there is previous result. Oh, where is it? Okay. So original equation was the following: cxx plus 2cxy minus 6x squared x, right? Cy x minus cx. We found the u is y plus x squared, v is y minus 3 over 2x squared. So cx, cu ux plus cv vx is cu 2x cv minus 3x is 2cu minus 3cv. So f is actually x, zx is 2x, 2zu minus 3zv, right? That's your f side. And this is hyperbolic equation, right? So alpha and gamma is 0. Beta is 2ux free x plus b is x, ux free y plus, so this is b, uy free x minus twice over b, right? Beta twice over 6x, 12 x squared, uy free y. So twice ux is 2x minus 3x. X times ux is 2x, free y is 1, uy is 1, free x is minus 3x. And uy free y is 1, right? So it's 12 x squared. So minus 12 x squared minus x squared minus 12 x squared is minus 25 x squared. All right. Delta A u x x e u x y c u y y. So this A is equal to 1, right? And uxy 0, right? uyy 0. So just 2. Epsilon A free xx b free xy c free yy. So xy is 0, right? Yy is 0 because, so if we differentiate to xx is minus 3. Minus 3. So our differential equation is the following. Minus 25 x squared z u free plus beta 2 z u minus 3 z free. It turns out to be x minus cx, right? cx 2zu minus 3zv. If you take a look at here, right? So nice thing is this cancels each other, and so we have some more space here. Oops. This is 2, this is 3. So what do we have? So minus 25 x squared z u v is equal to 0, or actually it doesn't matter whether we have 25x squared. You can say z u v is 0, right? So the general solution is z can be as a phi over u plus psi over v, or phi of y plus x squared plus psi of y minus 3 over 2x squared is a solution. Okay. And I'm going to leave a parabolic and elliptic case for after the case. And for partial differential equations, I didn't cover in previous lectures. So you have to find some examples from existing books, whatever engineering math books. You can find some problems, or Wikipedia. They might have some examples. So unless there is objection, I'd like to stop here today. It's a bit early, but how about that? It's okay? Okay, before I proceed, let's save.